Yes, good afternoon, all of you. Let's start our today's session. This will be last session for machine learning terminology, and then in next lecture we will discuss applications of machine learning and supervised learning and unsupervised learning, some tools and techniques which are used in machine learning that we will discuss. Okay, we will go step by step in that direction. So, till now, we have discussed so many terminologies. Okay, so many terminologies means let's say we have started with you can say accuracy, algorithm, attribute, bias, then categorical variable, classification, confusion matrix, convergence, then deduction, dimension, epoch, features, feature selection, hyperparameters, induction, label, learning rate, loss, what is machine learning, model, neural network, noise, observation, outlier, overfitting, and parameter. Let's discuss few more terminologies uh, which are related to the machine learning. Precision. Okay, so if we discuss the precision, okay, so precision is let's try to understand precision in terms of binary classification. Okay, in terms of binary classification. So, how you people are defining precision in your regular terminology or in a normal conversation or in routine? What is the difference between accuracy and precision?
Accuracy of multiple short term, suppose 100 money, 50 short term, about like error.
Mhm.
50 short term and main market, we can say that 50%. Precision is for like one, like give to daily kind of like by first week, second week, third week.
Okay, good. Anyone else? Accuracy will be measured in terms of percentage. Okay. Precision. Precision means, let's say your correct decision. Okay, your correct classification is how much far from the classification boundary. Okay, sometimes what will happen that if we take a very simple example of let's say hot water and cold water, hot water and cold water. Okay, then if I will mix a bit amount of cold water in hot water and then I will try to then I will give you people to identify it. Okay, then you will try to identify whether it is hot or whether it is cold. Okay, you will say it is hot. It is hot. I will add some more cold water. Again, I will ask you. I will add some more cold water. Then I will ask you. Okay, so up to some limit, you will be able to identify it as a hot water. Okay, but beyond that limit, okay, you will start identifying it as a cold water. Okay, now this range will be separate for all the students, for all the person. Okay, so what we can say, the precision of each person is different. Precision of each person is different. That means ability to identify true class, ability to identify true class, it is known as precision. Okay, so how well you people are identifying hot water as a hot? Okay, it is your precision. What is accuracy? Accuracy means out of let's say 100 sample, in how many sample you have correctly identified uh, hot water. Okay, so percentage. Let's say you people have identified 70 percentage or 80 percentage sample as a you can say correct classification. Okay, but in let's say out of this 70, how well you have identified those as a class true object. That is the precision. Precision. Okay, so how well your algorithm is learned. to identify true class object. Okay, in case of binary classification, and in case of multi-class classification, it will be like how well your model is trained to identify a particular class object very well. Okay, not only identifying it, but very well. Okay, so this is something like generalization and specialization. Okay, so if you will identify more object of class 1, that means it is generalized. Okay, but those more object, if you are identifying with specific characteristics, okay, that will become your precision. Okay, so accuracy, in simple word we can say accuracy will be further classified into precision, that how well you are identifying it. Next is recall. So what do you mean by recall in normal terminology or in general terminology? Huh? Calling again? That means, okay. Anyone else? Anyone from class would like to give input on this? Recall. Recall is like allergy. Recall is like allergy. Yes. Recall is like allergy. If I will give you analogy, then you will be able to understand it very clearly. Now, if you look at the formal definition, then what is the formal definition? Also called the sensitivity. In context of binary classification, recall measures how sensitive the classifier is at detecting the positive instances. Okay, so if you are allergic to something, okay, then your sensitivity for that particular thing will be very high. Okay, for example, dust, allergy of dust. Okay, so if I will all of a sudden if I will bring you people into dusty environment, then what will happen? You people will start sneezing. Okay, गुजराती में जिसको बोलते हैं छींकना. Okay, so हम लोग छींकना, खांसना शुरू कर देंगे till everything gets normal. Okay, that is one type of sensitivity. Another type of sensitivity, if I will give, let's say some people are having sensitivity to the sword test. Okay, so if I will give them sword test, they will have cold or fever or temperature. Okay, so those kind of reaction. So recall means ability of class, ability of model to detect the object of a particular class. That how well you have trained your model to detect a particular class object. Okay, so if you are working with binary classification, then you will be, your algorithm or your model should be focusing on true class sensitivity. Okay, it should be able to identify true class very well. In multi-class classification, it should have sensitivity, equal sensitivity for all the class. Okay, if it is your requirement. If you want to train your model for multi-class, then your model should have equal sensitivity for all the class. So all the class object can be identified correctly. Okay, this is also kind of learning you people are doing before the exam. Okay, so you will be like, let's say you will have higher recall for some chapters which are your favorite. Okay, so if there will be question from that unit, you will very quickly you will respond to those chapters. Okay, but in rest of the cases, you will struggle to figure out that from which chapter this topic is belonging. Okay, so that is your recall, or you can say your sensitivity for particular chapter. Okay, so in terms of machine learning, sensitivity, recall is sensitivity to detect the object of a particular class. Clear, all of you? Let's move forward. Recall versus precision. So this is what we have discussed. Okay, so precision, you can say precision will be percentage of true guesses that were actually correct. If we guess one image is true out of 100 image and that image is actually true, then we can say that our precision is 100%. Our precision is 100%. Our results aren't helpful, however, because we miss the remaining 90 percentage or 99 percentage of class. Okay, so out of 100 images, if one image is identified correctly, that means it whatever we have identified true. Okay, that is already will belonging to the class 2, so it is having 100% precision. Okay, so ultimately precision and recall will depends on this confusion matrix. It will depends on this confusion matrix. Okay, ideally there should be only two value: true positive and true negative. Ideally, if your model is trained very well, then in confusion matrix it should have only two value: true positive and true negative. False negative and false positive is showing the problem. It is showing the problem. Okay, false if false objects are detected too much, okay, then we can say FP rate, false positive rate of your model is higher. Okay, why? Because it is diverted toward detecting the false object, or you can say negative object. Okay, and if we are getting true positive and false positive, then we can say our model is trained to detect the true instances of the instance of the true class, or you can say class 1. Okay, so that is also creating problem. So our model should be trained in a such a way that all the samples, means all this figure must fall in true positive and true negative only. Okay, false negative and so false positive both should be zero in ideal, or you can say 100% perfectly trained model. Okay, but you people know that this is a optimization problem, so it will be never possible. Okay, in a very pre-trained data or very limited number of data, you may get true positive and true negative value. Okay, but whenever you will work on real life scenario, this will you will get value in all four cells. Okay, that is true positive, false negative, false positive, and true negative. Okay, so if all the attribute, or you can say all the instances are in true positive, okay, means there is not any false negative object or false positive object, then we can say precision of the algorithm is very good. Precision of the algorithm is very good. What is recall? So if we compare it to the previous example, let's say in previous example we have taken the 100 images, okay, 10 with the brain tumor, and out of that we have guessed one brain tumor properly. Okay, so precision is 100%, but recall is only 10%. Recall is 10% means our algorithm is not sensitive enough to detect that remaining 9 images of brain tumor. Okay, our algorithm is not sensitive enough to detect that remaining 9 image of brain tumor. Okay, are you clear with the precision and recall? Okay, precision means how well it is able to detect that particular class. Okay, so out of, let's say, 100 are identified as a positive, then if all the 100 are positive, then we are having 100% precision. So in terms of true positive, okay, if all are belonging to true positive, okay, not No, none of is belonging to false positive. That means our precision is 100%. Okay, but yes, huh? Yes, if all will belong to true positive and all will belong to true negative only, there is neither false negative, neither false positive, then precision and recall both will be 100%. Recall and accuracy. What is recall? Sensitivity. Okay, so how well your object is trained to detect the, uh, you can say, object of particular class. And what is accuracy? Accuracy is simple as statistics. That out of 100, how many you have identified, how many objects you have identified correctly. Okay, so in many cases, what will happen? The accuracy and recall both will be same. Okay, so you will have confusion that, sir, in that case, recall and accuracy both will be same. Okay, but accuracy is not only ways, or it is not a only way to, you can say, measure the performance of training algorithm. Okay, like let's say how well you people are performing in written exam. It is not the only way to know that how well you have learned. Okay, so that's why we are having various components like lab experiment, continuous evaluation, and let's say assignment kind of thing. And you will be evaluated via all these components, and then cumulatively your final gradation will be there. Okay, so accuracy is a simple measure, but it will not define that how well we have trained our model or how robust our model is to work in real life scenario. Yes, regression. So this thing you people have already studied in your 11th and 12th. Okay, they will give you 2 points, and then they will ask you to find out the equation of line that is passing through this 2 point. That is passing through this 2 point. Okay, so what is regression? In regression, you will try to find out a hyperplane or shape. Okay, and based on that, you will try to predict the new or future value. Okay, now here you will try to find out that value, okay, that shape in such a way that there is a minimum error. There is minimum error. Okay, now error will be in terms of distance of point from the hyperplane. Okay, that we will see whenever we will see regression. At that time we will see. Okay, so error will be distance of point from that line, or you can say hyperplane. Okay, we will find the distance of all point from that hyperplane. In whenever we will use regression, at that time we will learn, or you people will come to know that it is not possible to find out a hyperplane on which all the points will lie on same plane. Okay, all the points will lie on that plane only. Okay, definitely some points will be left out, okay, from that plan. And that why? Because we have set the threshold. Okay, so if you will set threshold to 100%, then your algorithm will iterate into the loop for infinite amount of time. It will try to find a hyperplane, or it will try to find a line which will accommodate all the points whatever you have specified in data set. Okay, but once you say that no problem, 10 percentage error is acceptable or 10 percentage points are not part of plane, it's fine. Okay, so regression, we will try to predict a continuous variable with the help of function. Okay, and example are, let's say, price and sales. Next is regularization. Let's try to understand with this example, regularization. Regularization means you people will mug up something, okay, for final exam. But how I will know that you people have learned it properly or not? I will give you some unseen example. Yes, by asking some unseen example. Okay, so I will come to know that no, you people are not ready for exam. Okay, so what I will give you, what I will do, I will give you more example, okay, which are related to topic. Okay, so what is the need of regularization? Whenever you will train your algorithm too much or many multiple epoch on same data set, then your algorithm will be overfitted for that data set. Okay, it won't be able to predict the correct class for the sample which are not belonging to that data set. Okay, so what is regularization? Regularization is a technique utilized to combat the overfitting problem. Okay, it will solve the problem of overfitting, and this is achieved by adding complexity terms to the loss function that gives a bigger loss for complex model. Let me remove this part. Let me tell you in simple word. What we will do, we will create different data set from existing data set. Okay, let's say if you are having 1 lakh sample, then I will create 5 or 10 data set of 50,000 sample. Okay, and then I will train the model using this 50,000 samples one by one. Okay, first I will train using first data set, then I will train using next data set, next data set. So I will try to generalize my model. Okay, so if I will train model using all 1 lakh sample at a time, then it may result into overfitting. It may result into overfitting. But if I will create some random data set out of existing data set and I will train using those random data set, then my model will be more generalized compared to the overfitted model. Overfitted model. Okay. So these are actually technical terminology. So if you can recall this loss function, okay, then it will be easy for you. Reinforcement learning. Reinforcement learning means I will ask you same question in lots of different ways. Same theory in lots of different questions. Okay, so that is an example of reinforcement learning. I will try to teach you using different ways. Okay, what is a formal definition? Training a model to maximize reward via iterative trial and error. Okay, I will ask you one simple straightforward question. If you will answer it correctly, then I will ask from another way. Okay, then if you are not able to answer it correctly, then I will ask it another way. Okay, so till you are not generalized, till you are not able to learn that particular class very well, okay, I will keep asking you question in iteration. Okay, so it is iterative trial and error method. That is reinforcement learning. Receiver operative characteristics, ROC code. This is the most important terminology, and this will give you idea about, let's say, your training model. Okay. Now, whenever you will draw any ROC curve, okay, if the area under that ROC curve it is increasing, area under ROC curve is increasing, then your model is getting trained properly. Then your model is getting trained properly. Okay, but if it is decreasing, okay, let's say on y-axis it is starting with higher value, but gradually if we move towards the higher value of x-axis, it is lowering. Okay, then we can say area under of area, or you can say ROC. Okay, receiver operative characteristics or area under the ROC will be decreased. Okay, so your model is not learning properly. What is it? What is ROC? So plot of, you can say graph of true positive red versus false positive red. True positive red versus false positive red. It is known as ROC. It is known as ROC code. Okay, and it is a measure which is used to know the learning ability of your class or of your model. Okay, so there are lots of terminology used in machine learning except accuracy. Except accuracy. Now, if I will show you the output of Veka tool, okay, then you will be able to understand the output which you are getting there. Veka in laboratory session we have used Veka tool. Okay, so okay, now you will be able to understand that output. Okay, at that time, many students have asked me that, sir, what is this TP rate? What is sensitivity? What is type 1 error, type 2 error? Yes? Ah, false positive. So gradually what should happen? Gradually false positive should reduce and true positive should increase. Yes. Okay, so if area under the curve is increasing, okay, that means you are going incorrect. Next is segmentation. So partitioning your data set into different part and then training those part, then using those part for training purpose. It is segmentation. Segmentation will basically allow you to create the testing data set and training data set. Okay, let's say in this whatever we people are or you people are learning right now, what how it is going on, you people will go with the official chapters. Okay, so that is training part. It is used to train you. Okay, but unsolved exercise at the end of each chapter, it is testing part. It is testing part. Okay, it will be used to test you people whether you have learned it properly or not. Okay, so similarly, data set will be divided into parts. Okay, and we will have separate training test and separate testing set. Okay, so we can have idea that how well our algorithm is trained. So segmentation will allow us to partition the data set into multiple distinct data set. But here, difference between partitioning and segmentation is that while we will work with the segmentation, in each data set we will have object of that same class. Okay, in each data set, let's say if we are having 10 classes and if we are creating 10 segments, then in first segment we will have all the samples of class 1. In next segment we will have all the sample of class 2, class 3, class 4, class 5, class 6, likewise. Okay, and what we will do in partition, entire data set will be divided into, let's say, 4 or 5 parts. Okay, we don't know what is the distribution of samples in each partition. Okay, so segmentation is like, let's say you people are creating segment for particular class. So the sample of same segment will have similar characteristics, and sample of different segment will have more difference in similarity, in terms of similarity. Specificity. Okay, now let me tell you, all these terminologies are not available in all the machine learning tools. It is not available in all the machine learning tools. Okay. So if you will use multiple machine learning tools, then you will come across these multiple terminologies. Specificity. So in terms of binary classification, specificity measures the model's performance at classifying negative observation. Okay, what is the difference between specificity and recall? Specificity and recall. Recall is
positive to negative, but the true state is like up to unsuccessful.
Yes, exactly. And what is specificity? Yes, specificity will focus on true negative part of confusion matrix. Yes, yes, yes. Recall is focusing on true positive and true negative both. Recall is focusing on true negative and true positive both, while specificity is focusing on only and only true negative. Okay, so learning can be two type of learning: positive learning and negative learning. Positive learning means how positively, how well you are able to detect the object of positive class, and specificity means how well you are able to detect the object of negative class. Okay, so specificity is kind of negative learning. Okay, so if your model is trained very well to detect the negative object, okay, then it can be very helpful. For example, let's say if you are designing a self-driving car, okay, and if you are designing a self-driving car with computer vision, okay, and if the specificity of that car is very high, okay, means it is able to detect the various conditions where accident can take place. Okay, so it will be very good. It will be very good. Why? Because it will improve the safety. It will improve the safety. Okay, but if the specificity is very low, okay, then let's say it will treat human and animal and all these things. For example, Tesla is treating human, animal, then pole, okay, bridge, all these things as the same object. Then what will happen? Okay, specificity is very low. Okay, it is not able to detect the negative class. Okay, so that is specificity. Last four terminologies. Supervised learning. Okay, so whenever your algorithm will learn with level, it is supervised learning. Whatever you people are doing right now, okay, that is a kind of supervised learning. Okay, I am giving you knowledge with level. That is a supervised learning. Okay, another good example, whenever you started your primary education, okay, your class teacher may have asked you to write down one, okay, and your class teacher will ask you to repeat that same pattern multiple times. Okay, after that, once you have repeated that pattern multiple times, your teacher will give you label that this is one. This is one. Okay. If I will put two and if I will ask you to identify this digit, then what you will tell? You will tell it as a two. Why? Because that label you have received from your teacher. Yes. Yes. It is spent. Okay, but so whenever someone will tell you label, what you will do? You will try to find out the features of that label. Okay, if I will tell you that light, okay, then you will imagine like white color, bright light, or orange color, red color. Okay, something which is a source of light. Okay, then you will identify. Means by level you will identify or you will try to imagine the features. Okay, but what will happen? What is the best example of unsupervised learning? If I will put all of you into some unknown country, then what will happen? You will try to understand using facial expression, culture. Okay, so yes, so those are the attributes. Okay, those are the attributes. So instead of learning using label, what you will do, you will start learning using attribute. So that is unsupervised learning. Okay, you don't know label. Okay, but based on the characteristics, you will try to understand. You will try to categorize it. Yes. Ah. No. Then we will that level we will test. Result, it will give you result window. Why? Because you have trained that algorithm with the feature of friend, but level of window. Okay, so same thing will happen in routine also. Okay, if I will tell you, if I will show you tomato 100 or 1,000 times, and I tell you that this is cherry, this is cherry, this is cherry. Okay, then if in future someone will show you that tomato, then once you will think that this could be cherry. Because why? Why? Because I have told you 1,000 times. I have told you 1,000 times. So your brain is trained to detect it as a cherry for 0.01 percentage probability that this could be cherry. Okay, so that is supervised learning, where you will have label and you know the characteristics of that sample. Test set and training set. So those example I have already given you. That whatever chapter part is there, it is training part. And whatever unsolved exercises are there, that is test part. Okay, what will happen if we will learn or if I will teach you unsolved exercise in lecture or lab as well? Huh? So, yes, it will come into the training set. Okay, so your performance in exam will be biased. Your performance in exam will be biased. Why? Because I have trained you for those testing set. Yes. Okay. But if I will, yes, that's the thing. Now I think it will be more clear. Okay. Transfer learning. So whatever you people are learning from your friend, from your parents, that is the example of transfer learning. Okay, there is a good proverb that life is very short to experience everything. Okay, you must have to learn something from others. Okay, so whatever you will learn something from the others, that is the example of transfer learning. Yes, no, the people who are learning from others' experience. Yes, best example of transfer learning, let's say Google has trained the AlexNet or GoogleNet. Okay, that existing pre-trained network, you will get it. You will modify it as per your requirement. Then 90% of your learning you will acquire from Google, and 10% training you will give, and that remaining 10% learning you will give by your own. So as I told you, test and training we already discussed. Last but not least, type 1 error. Yes, this is really last one. Type 1 error. It is false positive that we already discussed. Type 2 error. It is false negative. Okay. These are from the confusion matrix. Underfitting. So what was happening in overfitting? Yes, what will happen in underfitting? Inverse of it. Yes, you won't be able to learn anything. Your model won't be able to learn anything. Okay, if you will put all type of data in your data set, then it may happen that underfitting may take place. Okay, let's say if I'm training model to detect the fruits. Okay, but if I am putting samples of fruit, vegetable, toys, bike, car, human being, all the animals. Okay, now just imagine what will happen. What will happen? What is our purpose? Our purpose is to detect the fruit. But what we are putting inside training model, everything. Okay, so model will be underfitted. Okay, so underfitting occurs when your model overgeneralized. It is overgeneralized. and fail to incorporate relevant variation in your data. Universal approximation theorem. Very hardly or very rarely you will come across this terminology. Okay, so this is something like, let's say if I am giving you training to drive a vehicle in range of 20 kilometer per hour to 40 kilometer per hour. Okay, and I'm putting you in, I'm putting you on F1 track for testing. Okay, then definitely you will be failed. Why? Because to manage the steering, clutch, brake, and lever, whatever you people have learned, it is in range of 20 kilometer per hour to 40 kilometer per hour. Okay, but where I am testing you, 140 kilometers, 160 kilometers, or 200 kilometers. Okay, so same thing will happen in case of learning as well. If I am training an algorithm for the range of 2 to minus 2, and if I am giving ranges at 10 or minus 15 or minus 20, okay, then I won't get proper output. Okay, so that is an example of universal approximation theorem. So while you are creating any training data set, okay, you have to make sure that you provide a full range of samples into the data set. A full range of samples into the data set. Clear? Last one, unsupervised learning, that also we have discussed. Okay, that's it. We are done with the terminologies of machine learning. Okay, now in future if you will come across any terminology, then at least you will have idea that somehow or somewhere we have heard of this terminology, so you can interpret as per your requirement. So let's conclude today's lecture here. Okay, in tomorrow's lecture, we will discuss uh, applications of machine learning very quickly, because you people are already aware with it. You people have worked with the various programs like Vodafone India and other training sessions. So we won't go in much depth. Okay, but we will be focusing on more theoretical part. And then we will go with some techniques which are used in machine learning. Okay, which technique means which other domain knowledge is used in machine learning. Okay, all of you are requested to put your attendance